Hello bee nerds, I'm Christine McDonald from Rushing River Apiaries, and I just finished week 3 of my Bee Smart Challenge, where I'm reading an academic article about bee research every day, and then sharing a little bit out through social media on my Instagram. And then once a week I've kind of been taking the theme for that week and turning it into a bit of a longer form video here on YouTube. So this week I decided to learn some more about honeybee viruses. I kind of went in thinking that I wanted to learn more about just deformed wing virus, but then I ended up kind of getting interested in other things as I went and branching out a little bit. This was a thought-provoking week for me because there is so much worry and stress about bee disease, obviously, and yet a lot of these studies, they were really interesting information, but didn't have a lot of takeaways until I really thought about it at the end of the week and had a bit of an aha moment and said, no, there's a huge takeaway here, and I'll share that at the end of this video. So at first I wanted to learn a little bit more about the load that bees can carry, the viral load, so looking specifically at viruses, not fungal infections like nosema, not bacterial infections like European foul brood, American foul brood. I wanted to look at viruses specifically, and I wanted to understand a little bit better about how they can be present in a hive but not symptomatic. And it turns out that that is really common, and that viruses are pretty ubiquitous across hives. So most hives, if you ran kind of a panel on them, you would find viral loads, but they wouldn't be high enough to cause any symptoms or any real problems for the hive. So one study actually listed the ones that are frequently found just in like a dormant state in hives: black queen cell virus, deformed wing virus, acute bee paralysis virus, chronic bee paralysis virus, and sac brood virus. And then later in the week I actually learned about a couple more, one being Lake Sinai virus. And then there were others that don't even have names yet. They're just like, most of them are Varroa destructor, so VD1, VD2, and on and on. So there are lots that your bees might have, and you might not even know it because your bees seem to be doing well and thriving until something stresses the colony out or speeds up like the viral transmission in the colony. So things that can stress your bees out, obviously winter is a big one. That's why we tend to see more sicknesses coming into like late fall and then bees not coming through winter. Lack of feed can be a stressor. And then things that speed up transmission for the most part is varroa mites. So there are certain viruses that can be transmitted by varroa, and then some that can even be like replicated in the mite so that it's taking off even faster, that every bite is a little bit stronger. So I did spend a day or two looking specifically at deformed wing virus because it is one of the most, like the biggest killers of bees, especially in North America where we are. And part of that is because it has all different paths of transmission. So deformed wing virus can be found at all stages of life. A honeybee egg can be infected with deformed wing virus, all through the like larval and pupal stages, and then obviously adults can have it, and that's where we start to see symptoms of it. But what that means is that it can be transmitted vertically. That means the queen can be infected and she can lay an egg that is infected. It can be transmitted horizontally. That means an infected worker feeds or interacts with a healthy worker and passes the virus on. So it's going like in both directions, B to B. But when that's the only thing happening, typically the bees can control it. Where things get out of hand is when you add a mite load to that, because deformed wing virus is one of the viruses that can replicate in the mite. So that means a mite bites an infected bee, and then inside the bee, that virus is replicating. So they bite and they get a little bit. By the time they bite another bee, they have more of it. The virus has built up in the mite so that when they bite the next bee, they're giving even more virus. Not all honeybee viruses do that, replicate in the mite, but deformed wing is one, and that's why with a high mite load, it can quickly get out of control. That's why usually if you see deformed wings, if people are asking a question, well, you know, what's wrong with my bee, what's wrong with this bee, and they're showing a picture of a bee with deformed wing, everybody starts saying, it's mites, it's mites, it's mites. It is mites, but it's indirectly mites. The reason, so I looked a little bit more at this viral replication in the mite and which viruses were able to do that. The reason that bees usually stay asymptomatic if there are no mites, so why they can deal with these viruses, is that they come in orally or through the skin. Those are kind of the two options in the absence of mites, right? Something can get in like through the body, or it can come in orally. And there's pretty good immune protection on bees through both of those avenues. So the gut wall, for anything that is oral, is a pretty good protection. Not everything can cross from the gut wall into like it's not blood, the hemolymph and the full system. Likewise, their cuticle is this like protection on the outside of their body, so that most pathogens would kind of run into that and be held out by it. But when a varroa bites, that's more of an injection, right? It's being, the virus, whatever that mite is carrying, is being put right into the bee's system and circulation. So it gets to bypass those natural immune barriers that the bee has, and the bee is more likely to get it and to get more of it. So of some of the viruses that were mentioned in this one study about replication in mites, black queen cell virus and sac brood virus don't replicate in mites, or they haven't found them to yet. Later on in the week, I learned that Lake Sinai virus does not replicate in mites, but of course, deformed wing virus does, and does quite strongly. A really cool study that I read that was just from late last year, October 2024, this one was published, was about feeding bees orally an antibody against deformed wing virus. So these researchers actually developed, or they used chickens to like produce this antibody against deformed wing virus, and then they were able to feed it to honeybees in a sugar solution. Feeding antibodies doesn't work for mammals, so it's interesting because this is not something that can work in humans. That's why our vaccinations need to be injected. But it had been shown to work in other insects, and that's why they thought that there was enough promise that this might work that they gave it a try. And they found that the antibodies, so the fed antibodies, did diffuse through that gut wall. So the gut wall is pretty good at holding in pathogens, but the antibodies were able to make it through so that it could circulate. And it did significantly reduce deformed wing virus levels in infected bees. Obviously just in a lab setting, but still a pretty interesting and promising bit of research for future treatments against some viruses. So that's one I'd love to learn more about. I'll definitely be watching the research on that. I actually don't remember what sent me down this little off on this side quest, but I think I was just searching honeybee viruses and this one came up and I was like, I have never heard of Kakugo virus. And so I decided to read about it and read about it for a couple days. And this research was done in Japan. This is not a virus that we need to worry about here. It's not even something that they need to worry about in Japan. It's just interesting, but it is very interesting because what they did was they took bees that were aggressive towards hornets, so hornets that were trying to attack a hive. Bees that were aggressive toward those hornets, put them in one pool, and bees that ran away from the hornets and put them in another pool. And when they examined the brains of the aggressive bees and the escaping bees, they found that the aggressive bees actually had a virus called Kikugo virus in their brain. Kikugo means ready, particularly like in a fight, ready to fight sense. So that's where the name came from. But it was only found in the brains of these aggressive bees. And this was the first study ever to find a link between a virus, an infection, and kind of behavior, aggressive behavior in bees. So I wanted to keep learning a little bit more of that because I thought it was cool. They did some more research on Kikugo virus after that first discovery. And they found that it was not, so in the first study they were just looking at guard bees because those are the ones that have the option to kind of fight or run. They looked at other workers, and it turns out that other workers could also be infected, but in nurse bees, like hive bees, it was more often found in their abdomen instead of in their brain. The virus itself is really closely related to deformed wing, but it seems like varroa mites can spread it. They can like get a little from one bee, pass it on to the next bee, but that it's not replicating in the mite. So it's not exponentially kind of growing in the presence of mites. And then on the last day, I wanted to look at Lake Sinai virus because I have heard of it, but I have never really learned much about it. And I kind of wondered why. Why do I hear and learn so much about deformed wing virus, even without effort? And yet I've heard of this one, but nobody seems to be sharing a lot of information about it. And it seems like there's a good reason for that, and that's that it's not really a virus that we need to worry too much about. It is present here in North America. It's pretty widely present, found in this study in about 30% of colonies that were surveyed, but it has a pretty stable relationship with bees, and that's probably because it doesn't replicate in mites. In fact, when they found Lake Sinai virus in bees, it was strongly related to, or not related to, like associated with nosema. So higher nosema, we would often find higher Lake Sinai virus, but it had the opposite relationship with mites, which is like, this is just one study. There might not be any causal link here, but higher Lake Sinai virus was found with lower mite loads, and as mite loads got higher, it got lower. I don't know what to make of that. They didn't really offer much in terms of explanation, but so that was my study on honeybee viruses this week. I found it all really interesting, and the aha moment that I had, the common thread through all of these articles, was that bees do okay against viruses in the absence of stress. And we might not have a lot of control over the viruses that come into our hives, or if we're buying nukes, the viruses that come with those, because so many of them are asymptomatic. You wouldn't even know that you have them, right? But what we do have some control over is the amount of stress that our bees experience. If our bees are hungry, if they're flying and there is no forage for them to find, that is stress. That is stress that we can control because we can feed our bees when they're hungry. If our bees are cold and they're having to expend a lot of energy keeping themselves warm, that is stress. That is a stressor that we can control because in the winter we can insulate our hives. And there's even some evidence that we should maybe be insulating all year round. Pesticides are stress. Now, we don't have a lot of control about where our bees forage and pesticides that they might get into in the field. We do have some control over the varroa treatments that we use in our hive, and that's worth considering. Are we treating only when it's necessary, or are we treating just all the time and without kind of testing or knowing that it is necessary? Are we using chemicals that are stronger than others or create more stress than others? All of those things can add to the stress that our bees are carrying. Or are we letting mites get out of control? Obviously, that's a huge stressor and also a way that these viruses replicate. So we can take a lot of actions to reduce the stress that our bees are under so that they can maintain more of a stable relationship with the viruses that are found in the hives. And that is my little TED Talk for today. Thanks for watching. If you like this format of video, I'm going to do one more next week to end off this month of the Be Smart Challenge. But I definitely am interested in continuing, specifically if you have topics that you would like to learn more about. So please let me know in the comments and subscribe if you have not yet. And I will see you next time.